Let's look at sketching polynomial functions. So for example, f of x equals negative 2 times x plus 3 quantity squared times x minus 5. So first, we'll determine the end behavior. So if this were multiplied out, right now it's factored, but if it were multiplied out, we'd have as the leading term a negative 2 times x squared times x. So negative 2x squared times x, which is negative 2x cubed. So remember, we can determine the end behavior from this leading term. So here we have an odd degree and a negative leading coefficient. So that means our end behavior is pointing up on the left and down on the right. So our end behavior is up and down. Next, let's find the intercepts. So let's find our x-intercepts first. So we've got that negative 2 out in front, but negative 2 is never going to equal 0, so we're not going to get an x-intercept from that. If there were an x out there with that, so like negative 2x or negative 2x squared, we would have to set that equal to 0 and solve for x to get an x-intercept. I'm going to go to the next set of parentheses, the x plus 3. I'll set x plus 3 equal to 0. Subtract 3, I get x equals negative 3. So one of my x-intercepts is negative 3, 0. Go to my next set of parentheses, x minus 5. Set that equal to 0. Get x by itself by adding 5 to both sides. So I get x equals 5. So my second x-intercept is 5, 0. So I have two x-intercepts. For our y-intercept, remember we have to substitute 0 in for x. So it's the same as finding f of 0. So that means we're finding negative 2 times 0 plus 3 quantity squared times 0 minus 5. So simplifying, we get negative 2 times 3 squared times negative 5. We have to do our exponents first, so negative 2 times 9 times negative 5, or negative 18 times negative 5, which is 90. So our y-intercept is 0, 90. So third, let's determine the real zeros and their multiplicity. And then we'll use this information to determine whether the graph will cross or touch the x-axis at each x-intercept. So we found the x-intercepts, and those are essentially the zeros. So I'm just going to rewrite the function since it got a little confusing with all my circling and underlining. We've got f of x equals negative 2 times x plus 3 quantity squared times x minus 5. We have an x-intercept, or 0, at negative 3. Its multiplicity, though, is going to be this exponent, so 2. We have a second x-intercept, or 0, at 5, and its multiplicity, we've got an invisible 1 exponent, so its multiplicity is 1. So what this tells us is when the multiplicity is even, the graph will touch the x-axis, sometimes called bouncing back or turning around at the x-axis. And if the multiplicity is odd, then the graph crosses the x-axis. More specifically, if the multiplicity is 1, so if the horizontal line is the x-axis, it crosses over more or less like a straight line, like a linear function. If the multiplicity is 3, 5, 7, or any other odd number, but not 1, then again, if the x-axis is a horizontal line, then it does a little bobble when it crosses the x-axis. So for our first 0, negative 3, its multiplicity of 2, it's even, so it touches or bounces at the x-axis. And for the second 0 at 5, where the multiplicity is 1, it actually crosses the x-axis there. So will determine the maximum number of turning points. So this is found by simply taking the degree and subtracting 1. So our degree was 3, and we're subtracting 1, so 2 is our maximum number of turning points. That means it could have 2 turning points, but it could have less. And then 5, use all of this information to sketch the graph. So here's a graph. I'm going to have 2 different scales, one for the x-axis and one for the y-axis. So on the x-axis, every grid line is 1 unit. On the y-axis, every grid line is 10, just because our y-intercept is at 90. So I'll plot the y-intercept at 0, 90. I've got an x-intercept at -3 and x-intercept at 5. And remember, our end behavior was up on the left, down on the right. So I know if I start on the left, I have to start at the left on my graph. It's pointing up on the left. And it's going to approach that leftmost 0. And that 0 of -3, remember, it had multiplicity of 2. So that means it's bouncing or it's touching. It's going to turn around at the x-axis. Sorry, I didn't mean for it to go all the way. So it's going to turn around. It's going to go through the y-intercept. I don't know how high it's going to go up. That's why I kind of circled it. It could turn around at the y-intercept. We haven't done enough math to determine that. We could put in some test values for x and find out some more information. But we're just going to do a sketch. But it is going to come back down and go through that second 0 at 5. And remember, that had multiplicity of 1. It's going to cross there. So it actually goes across the x-axis there. And we didn't do enough math. Like, we could have put in some more x values and found the y values to find some more points to find out, did it actually turn around before the y-axis? Did it turn around after the y-axis? But it's a sketch. This would count as a sketch. And so this is about what the graph would look like, except we don't know how high the graph actually goes and where the actual turning point is. We know it turns around on the x-axis, but we don't know where that other turning point is.